In today's lesson on section 2.4, we're going to be talking about lines. Now I know you guys have dealt with lines a lot in the past, so a lot of this is going to be repeat information for you. But first of all, we want to remember what the word slope means and what we talk about when we're dealing with slope. And if you remember, slope is the value that we use to measure the steepness of a line. Now steepness is not a technical term, but it just helps us to get an idea of how quickly a line is going up or how quickly it's going down. We remember that slope many times we'll use a little phrase rise over the run. That's your distance that you're changing up and down compared to your distance that you're changing left and right. Or algebraically, the way we solve for that is that m, which we use to represent slope, is equal to the quantity y2 minus y1 over the quantity x2 minus x1. And then the y2 and the y1 are just the y values of two different points, and the x2 and the x1 are just the x values of those two different points. So for example 1, we're going to take a minute here to find the slope of the line that passes through the point A, which is 6, 2, and point B, which is -5, 3. In example 1, we're supposed to find the slope of the line that goes through these points A and B. To do that, we just use our slope formula. And so really this is just plugging in numbers. Since the y, we can choose whatever point to be first point, second point. So let's just choose this one as the first point and this one as the second point. So remember, you've got x and y and x and y. So your y value here is 3 minus the first y value, which is 2. Over here you've got x is -5 minus the x value here, which is -6. And so that gives us 1 over -11. And that's our answer for example 1. Just the slope is -1/11. Next, when we want to talk about some specific forms of the equations of lines, and the first one we want to talk about is the point-slope form. In point-slope form, we are given the slope, which is m, and we're given a point, and that point we're going to label as x sub 1, y sub 1, that ordered pair. The formula we're given is y minus y1 equals m times the quantity x minus x1. And basically, if you know a point and you know a slope for a given line, you can just plug those values, the y value in, plug in the slope value, and plug in the x value to get your equation for that. So for example 2, we're just going to do that one right here on the PowerPoint. It says find the equation of the line that passes through the point -5, 2 and has a slope of -2/3. Well, looking at the equation that we have above there, the y value that we're given is 2. So that 2 will go in place of this y1 right here. That's where the 2 will go. We also are given -5 as our x value, so that value is going to go in right here for the x coordinate. Finally, we have the slope, which is m, and that is -2/3, so we're going to plug that in place of the m. And we get this formula, y minus 2 equals -2/3, and then times the quantity x plus 5. In example 3, which hopefully you've taken some time to write down as we were looking at example 2, we're supposed to find the equation of a line that passes through the points 5, -2 and 1, 7. In example 3, we're given 2 points that we want to make into a line, and those 2 points are 5, -2 and 1, 7. Now when you're given a slope and an intercept, remember it's easy to use slope-intercept form. When you're given a point and a slope, we can use point-slope form. In this case, we're given 2 points, but remember, if we have 2 points, just like we did in example 1, we can find the slope, and then we will be able to use point-slope form. So let's go ahead and again use that formula for the slope. We've got 7 minus negative 2 and 1 minus 5. That gives us 9 over negative 4, or negative 9/4. So then the two options we have, we can use point-slope form for either one of these points. One option would be y plus 2, subtracting a negative, equals negative 9/4 times x minus 5. Or the other option, besides this one using this point, we can use this point. So that would be y minus 7 equals negative 9/4 x minus 1. These are the same equation, even though they look different. If you want to verify that for yourself, just go ahead and change both of them into slope-intercept form, and then you'll find out that both of these are the same. They just look different because we're starting with a different point. But you could actually have an infinite number of different equations using point-slope form, because you can use any point on the line along with this slope of negative 9/4. So either one of these would be correct based on these 2 points that we're given. Notice again we do have those two possibilities for this equation. Both of those will work. Next, probably the one you're most familiar with is slope-intercept form. And in this form we are given the slope m, and we're given a y-intercept, which we note as b, and then you know that formula, it's y equals mx plus b. In example 4a, again we'll do that one together here on the PowerPoint because it's just filling in the values. Find the equation of a line with a slope of negative 3 and a y-intercept of 6. So again, when they tell us here that the slope is negative 3, that's our m value. So that negative 3 will go right here in front of the x. When they tell us that the y-intercept is 6, that is going to go right here in place of the b, because we know that the y-intercept is the b value. So here we have y equals negative 3x plus 6. In the second part of 4b, we're supposed to find the slope-intercept form of the line 4y minus 6x plus 5 equals 0. In the second part of example 4, we are supposed to take this equation, which is written in general form, and rearrange it so that it's in slope-intercept form. Slope-intercept form, the key thing is you want to get the y value by itself, and then on the other side you want the x, the part that has the x in it, to be first. So to get the y by itself, the first thing we're going to do is add 6x to both sides, and also subtract 5 from both sides. So then we'll have 4y equals 6x minus 5. And the second step, to get the y by itself, we just divide by 4 each term. So we get y equals, you can reduce this is 3 over 2, and we reduce both of those by 2, x minus, and usually we'll just leave that as 5/4. If you want to change it to 1 1/4, that's fine. But there's your line in slope-intercept form. Again, the benefit of this is to graph lines that are in slope-intercept form, you just find your y-intercept, which is in this case negative 5/4, and then from that point you can use your slope to go up 3 and over 2 using that positive slope there of 3/2. Now when we're dealing with lines, we have to talk about vertical and horizontal lines, because the slopes of those are a little bit unique. And when we deal with a vertical line that goes through the point A comma B, the equation of that is, because the slope is undefined, the equation of that actually looks like, has the equation x equals A, whatever that A value happens to be. That x coordinate from the ordered pair is what will go there in that formula, x equals, or in that equation, x equals A. For a horizontal line, the slope would be 0, because it's just going straight from left to right. So horizontal line through the point A comma B has the equation y equals b. Again, whatever the y coordinate is from our ordered pair. Another type of equation for lines is what we call the general equation, and the general equation is when we have everything written over on one side of the equation, so it's set equal to 0, and we cannot have a and b both being 0, because then there would be no x and there would be no y, so you would not have a line there if both a and b were 0. So that's the one restriction we have there. A cannot be 0. A and b cannot both be 0. So in example 6, we're going to graph 3x minus 4y plus 12 equals 0. That is an equation in general form. So we're going to take a minute to do that now. For example 6, we're supposed to graph this function. Probably one of the easiest ways, other than switching this into slope-intercept form. Another easy way of doing this, and I think we looked at it briefly in section 1.2.1, is to change it into standard form by subtracting 12 from both sides. So it would give us this. At this point, we can find the intercepts very easily, because if you remember, the x-intercepts always happen when y equals 0. So for the x-intercept, we'll have 3 times x minus 4 times 0 equals negative 12. That just goes away, and we find out x equals negative 4. So that's the point negative 4 comma 0. For the y-intercept, it's very similar, but for every y-intercept, the x value is going to be 0. So that one will turn into this. 3 times 0 minus 4y equals negative 12. So that cancels out, and we get y equals 3. So that ordered pair is going to be 0, 3. Once we know that, all we have to do is graph those 2 points. And so graphing negative 4, 0, that's this point over here. Graphing 0, 3, that's this point right here. So we know that our line, if I could hit the dots, we know that our line goes through those 2 points and is going to have that positive slope. You could also change it into slope-intercept form. That would work as well. But especially when 3 and 4 both go divide evenly into 12, it makes this method very easy to work with. I just listed the intercepts here, but if you go back using those intercepts, it's very easy to graph that equation. Another important thing we deal with when we talk about lines is the idea of parallel and perpendicular lines. 2 non-vertical lines are parallel if and only if the slope of the first line is equal to the slope of the second line. And we probably remember that from our past classes, but if whatever the rate that the one line is going up at, the other one has to be going up at that same rate, or changing at that same rate. So those 2 slopes have to be equal. For example 7, we're going to find the equation of a line that is parallel to 4x plus 6y plus 5 equals 0 and goes through the point negative 2, 5. In example 7, we are supposed to find a line that is parallel to this line, 4x plus 6y plus 5 equals 0, and also goes through this point, negative 2, 5. So the important information, hopefully you realize this from the definition of parallel, the important information that we need from here is we need to know what the slope is. So our first step is going to be to change this equation into slope-intercept form. So taking 4x plus 6y plus 5 equals 0, we want to get the y by itself. We'll subtract 4x and subtract 5. That'll give us 6y equals negative 4x minus 5. And then we just divide everything by 6. So that cancels. We get y equals negative 2/3 x minus 5/6. And again, the important information we need from this equation is what is the slope. The slope here is always right in front of the x when it's in slope-intercept form. So negative 2/3 is our slope. If we want a line parallel to this, we're just going to use this slope, negative 2/3. So once we know the slope, we also have been given a point. We can use point-slope form to write this out. So point-slope form, we've got y minus 5, y minus the y value, equals negative 2/3 x plus 2. Now if we convert that into slope-intercept form, which most of the time we want to do, the way you do that is you just distribute the negative 2/3. That'll give us y minus 5 equals negative 2/3 x minus 4/3. And then the last step to get the y by itself for slope-intercept form, we add 5. And that gives us y equals negative 2/3 x. We need a common denominator here, since that's 5 over 1. To get our common denominator of 3, we multiply by 3 and 3. So that gives us, we're actually adding 15/3. So 4/3 plus 15/3, sorry, negative 4/3 plus 15/3 gives us 11/3. And that will be our answer in slope-intercept form. Again, the important thing to remember about this type of a problem is the piece of information that we need from that original equation is the slope, because whatever the slope is, for our parallel line, we're going to use the same slope. Now, two lines are perpendicular if the slope of the first line times the slope of the second line equals negative 1. Or another way of saying that is that the slope of the first line is equal to the opposite reciprocal of the second line. Algebraically, that's negative 1 over m sub 2. In this last example, we're going to find the line that is perpendicular to 4x plus 6y plus 5 equals 0, the same equation we used before, and also goes through the same point, but this time not parallel to, but perpendicular to. Now in example 9, we're going to find a line that's perpendicular to this same line that we used in example 7, and also through the same point. So I'm going to leave this up here so that you can kind of compare it. We have already solved for the slope, and we know the slope here is negative 2/3. So if the slope for this line is negative 2/3, the slope that we have to use for a perpendicular line is the opposite reciprocal. So it's going to be positive 3/2. So the slope we're going to use is going to be 3/2, but the point we're using is exactly the same. So again, we've got point and slope. We can use point-slope form. Notice we're going to fill this out almost identically. Y minus 5 equals, this time the slope is 3/2, x plus 2. So the point-slope form, the only difference is you change the slope. When we go ahead and change this into slope-intercept form, again, we're going to distribute. Y minus 5 equals 3/2 x plus, that's going to give us a 3. Then we add 5 to both sides, and we get y equals 3/2 x plus 8. And there is our line that's perpendicular. Notice you can't just change the slope in the slope-intercept form. You have to go back to the point-slope form and change your slope in there, re-enter your points, and then change it back into slope-intercept form. If you just change the slope here to a 3/2, what's going to happen is it will be perpendicular to this line, but it won't go through that point. Okay? What you're doing is you're locking it in at the y-intercept. So in order to do this, find your slope, use point-slope form, change it to slope-intercept. Do the same thing here. Find your new slope when it's perpendicular, point-slope form, change to slope-intercept form. Notice again, remember the important thing we need to find out from that original equation is the slope. This time we need to use a different slope. We need to use the opposite reciprocal. So since the original slope was negative 2/3, we have to use positive 3/2. Your assignment for this section is pages 189 and 190, numbers 2, 8, 12, 24, 26, 28, 34, 42, 44, and 53. You'll notice there's less problems involved. That's because I know that some of these problems will take you a little bit longer. Make sure you work those out and do any graphing that the problems ask you to do. All right, have a good rest of the day, and I will see you during the next class session.